A few years after Fugadi's paper appeared in the literature, I got a letter from the editor of the Canadian Journal of Chemistry. He said that Canadian Journal of Chemistry editorial board wanted to celebrate McGill University's Professor Arthur Perlin's 67th birthday by dedicating one of their monthly issues to Arthur Perlin. The editor invited me to send a paper to the special issue, and he said all papers will be refereed by two different referees in the usual manner. In 1950, Arthur Perlin was working for the Canadian Research Organisation in Ottawa, which is similar to the CSIRO here. He got sabbatical leave and spent a year working with Professor Hurst in Edinburgh. Hurst and Perlin worked on the polysaccharide from Acacia pycnantha, which is indigenous to South Australia. So I thought it would be appropriate for me to write up my own work on Acacia cynophila gum and send that to the editor of the Canadian Journal. I wrote a paper and sent a copy of that to Alistair Stephen because I was mixed up in the work with him. I suggested that he may like to be a co-author. He wrote back saying yes, he would accept my offer of being a co-author for two reasons. One, he wanted to join me in the special tribute to Arthur Perlin, and secondly, could make a contribution. One of his students, Neil Ravenscroft, had made a detailed NMR study of the disaccharide where L-rhamnose was linked to the 4 position of D-glucose. Ravenscroft confirmed the structure which I'd worked out by classical methods. In fact, he studied a disaccharide which I'd left in Cape Town 20 years before. Alistair Stephen wanted to include this work in the paper, and he asked me if I'd prepared to let Ravenscroft's name go onto the paper. Of course, I agreed to that. Ravenscroft was very pleased about this because he was going to do postdoctoral work in Canada, and if he had his name on a paper in the special issue, it would be of advantage to him. Anyway, in that special paper, I pointed out that you get the same structural feature in a number of bacterial polysaccharides and in 2 different gums. And I suggested in the biosynthesis of the plant polysaccharides, there may be a step where rhamnose from a bacterial nucleoside, diphosphate rhamnose, is transferred to the plant polysaccharide using a bacterial nucleoside transferase. In other words, a combined bacterial plant biosynthesis at the molecular level. Even although it's very well known that some bacteria can fix nitrogen and the ammonia produced can be used by plants, I thought the idea that I was putting forward might be considered way out. So I was pleased that the referees did not challenge it. I should note, though, that in one of his NMR works, Ravenscroft used a Russian method to confirm the absolute configurations of D-glucose and L-rhamnose. One of the referees challenged that, but Alistair Stephen was able to convince the referees that the Russian method was sound, and the paper was accepted. After the paper was accepted, I read Richard Dawkins' book on the ancestor's tale. In that book, Dawkins maintained that many years ago, bacteria played the role in plant cells which mitochondria play now. If that is indeed the case, then the idea of a combined bacterial plant biosynthesis is not way out at all. Hopefully, in the not too distant future, somebody might find an experimental method to test whether this idea of a combined bacterial plant biosynthesis is true or false. After the paper was accepted, I again started thinking about gum arabic. By taking into account some new experimental method about the structure of gum arabic and some educated guessing, I came up with this formula for gum arabic. I sent a copy of that to Alistair Stephen in Cape Town, and he said he was thinking along similar lines. A few years later, Alistair Stephen and Shirley Sherms gave a formula for gum arabic in a monograph on food polysaccharides. Shirley and Alistair and various other people like to use that type of diagram to depict the primary structure of these heteropolysaccharides.